students. Now when we take the graph between V and I, the graph is always a straight line. It denotes that when we increase the value of V, then value of I automatic increase in the same rate. Okay, now next one is the resistance. What is resistance? What is resistance? Now, resistance, it is a property of conductor to resist the flow of charge through it. Property of conductor to resist the flow of charge. To resist the flow of charge means the property of conductor to resist means to oppose the flow of charge, to oppose the flow of current, and it is denoted by R. It is denoted by R. Okay, resistance is denoted by capital R. We know that Ohm's law gives the formula V is equals to IR. So R equals to V upon I. It gives that V is directly proportional to I. Means the potential difference is directly proportional to current. First point is that the potential difference directly proportional to current. Second, the current is inversely proportional to resistance. When we increase the potential difference, the current also increase. When we decrease the potential difference, current also decrease. And when we increase the current, the resistance is decrease, because the resistance is a property of conductor to resist the flow of charge, means to oppose the flow of charge. Okay, now the unit of resistance. SI unit, we will discuss about previous videos that the SI unit of current is ampere, the SI unit of current, the charge is coulomb, the SI unit of potential difference is volt. Now similarly, the SI unit of resistance, is ohm, and it is denoted by this symbol. SI unit of resistance is ohm and it is denoted by this symbol. Okay, so R equals to V upon I. Resistance SI unit is ohm, OHM. Potential difference SI unit is volt. Current SI unit is ampere. So what is the definition of 1 ohm? Now we discussed in previous video that how we find the value of 1 ohm. When we find the value of 1 ohm, now 1, let 1 and let 1. So 1 ohm is the resistance when the current flowing through the conductor is 1 ampere and the potential difference between two terminals is 1 volt. Okay, the 1 ohm resistance is that when the current flowing through a conductor is 1 ampere and the potential difference flowing through the conductor between 2 points is 1 volt. Okay, now this is all about the resistance. Okay, this is all about the resistance. Let me take one example. When the current flowing through a conductor is 2 ampere, when the current flowing through the conductor is 2 ampere and the potential difference between two terminals of conductor is 10 volt. Okay, now find the value of resistance. Now how we find the value of resistance? We know that R equals to V upon I. So R equals to V. V means potential difference is the value 10 and the current value is 2 ampere. 2 5s are 10. So resistance is 5. Now the SI unit of resistance is ohm. So 5 ohm. So the value of resistance is 5 ohm. This one is the answer. Now next is wait. Now next one is the factor affecting the resistance of conductor. Next topic is the factors which affecting the resistance. Means the resistance depend on how much factors. The resistance depend on how much factor. So resistance depend on many factors, like at given temperature the resistance depend on following topics, like first of all the resistance depend on the length of wire. First the resistance is directly proportional to the length of wire. L is the length of wire. Second one is the resistance is directly proportional. Sorry. The resistance is inversely proportional to the area of cross section of wire. The resistance is inversely proportional to the area of cross section of wire. Okay. So the first is the resistance depend on the length of wire, and the second is resistance depend inversely proportional to the area of cross section of the wire. And the third one, the resistance is depend on the material of which the wire is made. The resistance depend on the material of wire which is made. Okay. Now so the in these 2 points, resistance is directly proportional to L upon A. Resistance is directly proportional to L upon A, because resistance is directly proportional to L, resistance inversely proportional to area of cross section. Now what is area of cross section? This one is not area of cross section. Area of cross section is this. This circular part is called the area of cross section. Okay. Now when we remove the directly proportional sign, so R equals to rho. This one is resistivity. Rho into L upon A. Rho into L upon A, where rho is called resistivity. Rho is called resistivity. Okay. So R is equals to rho into L upon A. Very important formula. Many numericals based on this formula. R equals to rho into L upon A, where rho is the resistivity. So where rho is the resistivity. Okay. Now, so what is resistivity? Okay. When we find the value of resistivity, then see, R equals to rho into L upon A. So rho equals to R into A upon L. Rho equals to R into A upon L. So what is resistivity? Resistivity is the resistance. Resistivity is the resistance when area of cross section is 1 meter square and the length of wire is also 1 meter. Clear? Resistivity is the resistance of wire when the area of cross section is 1 meter square and the length is 1 meter. Okay, so resistivity is defined as the resistance when unit length per unit area of cross section. Clear? So resistivity resistivity is defined as the resistance of conductor resistivity is defined as resistance of conductor of unit length. Unit means 1 of unit length per unit area of cross section. Per unit area of cross section. Per unit area of cross section. Clear? So this is all about resistivity. Now we find the value of SI unit of resistivity. Now we know that R equals to rho into L upon A. So rho equals to R into A upon L. Now rho equals to R resistance, SI unit is ohm, area meter square, length meter, meter to meter. Now rho equals to ohm into meter. So the SI unit of resistivity is ohm into meter. Okay, ohm into meter. Now the resistance of metallic wire also depend on temperature. The resistance of metallic wire depend on temperature because resistivity is depend on temperature. Okay, resistance of conductor increase as we increase the temperature. When temperature decrease, then resistance also decrease. This is logic. When we increase the temperature, then resistance also increase, and when we decrease the temperature, then resistance also decrease, because rho is the temperature. Rho is the temperature of material. Okay, resistivity. So resistance depend on temperature. Okay, now next one is, so this is all about, so very important formula, main formula is R equals to rho into L upon A. Okay, R equals to rho into L upon A. Now one numerical is that when we half the length of wire, when the length of wire is half, and area of cross section double, then what is the change in resistance? When the length of wire is half and area of cross section is double, means now L dash equals to L upon 2, and A dash, new area is 2A. New area is 2A. Now we know that R equals to rho into L upon A. This is before, but when we half the length, means now length is L upon 2. So resistance equals to rho into, replace L by 2, and area is double, means 2A. Now rho into L upon A is R. Rho into L upon A is R. So new resistance is R upon 4. Now new resistance is 1 upon 4 times the old resistance. Okay, thank you. This is all about numerical. In our next video we will discuss about the combination of resistance, like series and parallel combination. Okay, thank you for this.